Welcome to After Dark Online, Dust to Dust. Thanks for joining us again as we continue to explore our world through science, art, and conversation. My name is Sam Sharkland, and I'm a program developer as part of the team that produces After Dark. We're happy to be bringing this program to you virtually while our doors are closed, but the museum itself is located on Pier 15 in San Francisco, on unceded territory traditionally belonging to the Ramaytush Ohlone. We recognize that we are guests on this land, and we honor the conservation and stewardship the Ohlone have offered to our ecology, past, present, and continuing into the future. Tonight, we continue with our October After Dark theme, OK with Decay. We're looking at how and why things fall apart, at entropy, and what opportunities there are for the space left over for revisions and revitalizations. Tonight, in Dust to Dust, we're looking at geologic timescales and the processes that inform the transformation and destruction of the very Earth that we're on. And we're also very pleased that tonight kicks off our October residency with Odd Salon. Tonight they will be sharing stories of entropy drawn from the odd corners of science, history, art, and adventure. And we'll finish off the night with a newly recorded performance as part of our Resonance series, seeking to explore distant realms of musical possibility. So stick around for that. But at first, we have a conversation with author, scholar, and professor Dr. Marcia Bjornerud about the formation of the Earth and where we're headed. Marcia Bjornerud is a professor of geosciences and environmental studies at Lawrence University in Appleton, Wisconsin. A structural geologist, she has done field research in Arctic and mainland Norway, Arctic Canada, New Zealand, Italy, and the Lake Superior region. She is particularly interested in the mechanical nature of Earth's middle crust during mountain building. She has written on geological topics for the Los Angeles Times, New York Times, Wall Street Journal, Wired, and the New Yorker's Science and Technology blog. She's the author of 2 books for popular audiences, Reading the Rocks, The Autobiography of the Earth, and Timefulness, How Thinking Like a Geologist Can Help Save the World. Timefulness was a finalist for the 2018 LA Times Book Prize in Science and Technology and a finalist for the 2019 Phi Beta Kappa Award in Science Writing. It was really a pleasure to get to connect with Dr. Bjornerud and have this conversation with her. We hope you enjoy as well. Thank you, Dr. Bjornerud, for joining us this evening as we talk about the geologic forces that have created Earth. I want to start, though, by asking you a bit about how you came into this field and where the direction your research is taking and how it's kind of expanded some of your thinking about the world.
Well, like many people, I had almost no exposure to the geosciences in school, in high school. And I just happened to take an introductory geology course as a first-year student in college, mainly to fulfill a laboratory science requirement, frankly, and had fairly low expectations for it. It's probably not the case in California. People may be more aware of geology as a distinct discipline, but here in the Midwest, our geology is maybe a little subtler, and it just wasn't something I'd run across. So to my surprise, this course, which a lot of people called Rocks for Jocks, was amazingly mind expanding. It really was, in some sense, the etymology of the world. I had always been interested in word origins, etymologies of words. And when I began to understand what the field of geology was about, I realized it was the explanation for how the world came to be the way it is. And for me, and I think for many other people who serendipitously come into this field, that's the attraction, that we see that the landscapes around us are not an arbitrary constellation of hills and valleys. There's a reason things look the way they do. And I think for me, that feeling that there's a logic to the landscape, and that the land is in some way a text that can be read, was deeply appealing. And I feel very lucky. I mean, at 17, who knows where your life is going to go? But there was something in geology that I recognized even at that age that continues to nurture me intellectually, and I would say even spiritually in some broad sense in my late middle age. My own field that I ended up going into is structural geology and tectonics. And I think I got into that largely for aesthetic reasons. I really like the beauty of folded and deformed rocks. They have a kind of majesty to them. And I became interested in just the whole process of mountain building and how we could reconstruct something that grows as slowly as a mountain belt by looking at mountains in different stages of formation and decay in our time. So that's what my focus of my research for the last 30 years has been, in different places around the world, including the Midwest, where we have the deeply eroded remnants of mountains, trying to understand in something like real time how the crust rumples and crinkles and forms mountains.
Yeah, and you talk about being able to read the earth like a text, and that there is some deeper level of understanding. And though there are changes that we can perceive on our scale, the implication is, and that geology has allowed us to kind of see deeper in time, and that the earth is actually transformed quite a bit beyond what we can perceive in our own lifetimes. Can you talk a little bit about how dynamic the system is, and maybe give us a bit of the story of how the earth even came to be?
Right. So the earth has really had a long biography, and it's gone through different stages, almost like a human. We can look at the infancy of the earth, the childhood, the adolescence, and it's sort of in late middle age now. So the earth, of course, is not an only child. It's one of a set of siblings. The other planets in the solar system and all the other objects, including the sun, came into being at the same time. So we're part of an extended family, of which the sun is the big parent. And the material that makes up all of the objects in the solar system is itself recycled stuff from earlier stars. As Carl Sagan was fond of saying, you are star stuff. And a solar system like ours that has a fair mass of rocky stuff, the rocky inner planets, couldn't have come into being in the earliest days of the universe, because we needed time for precursor stars to manufacture heavy elements over long periods of time. So that's what stars do. They forge heavy elements in their cores, and then they make other elements even beyond iron when they blow themselves up in supernova explosions. So we needed a certain number of ancestral large stars that could forge heavy elements initially in their cores during their lifetimes, and then even heavier elements when they blew themselves to bits, to even have the raw materials that could go into making planets like the Earth and the other rocky planets. Mercury, Venus, Earth, and Mars are the rocky planets before. So we couldn't have come along till about the time that we did, and that was about 4.5 billion years ago. And so all the ingredients of our solar system are recycled. And then the next big chapter would have been something energetic. We're not entirely sure. Maybe another supernova nearby in our neck of the galaxy, or maybe the current thinking in the last year or so is that two neutron stars might have collided. Something energetic happened and kicked what was otherwise a kind of diffuse nebula of gas and dust into motion, started rotating and collapsing on its own, under its own gravity. We can see analogs of that in deep space. They're called protoplanetary disks. And at some point, enough of the mass of that disk concentrated into the center to become the sun. And the sun ignited, started doing that nucleosynthesis in its core. And at that point, all of that gas and dust was sorted by temperature into the rocky stuff, the gaseous stuff, and then way further out, the ice bodies, including Pluto and the comets, which sounds like a great band. So we were part of that rocky material in the inner solar system. And the next chapter in our story was that there was enough heat for what was originally just a rubble heap of rock, essentially, asteroids sort of loosely associated by gravity, to melt. And in that melting, then have the potential to start separating into different components, namely metallic cores and rocky mantles. And that's really the prerequisite for being a proper planet, having differentiated into those components. And we have a very good record of both the original accretion of those sort of rubble heaps and the differentiation of some early planets that later got blasted apart in meteorites. So we actually have a really high resolution record of the very earliest days of the solar system and Earth's formation. Higher resolution than the first 500 million years of Earth's own biography, because just like infant humans, the Earth doesn't actually remember its earliest days. But meteorites, which formed in the very earliest days of the solar system, nothing has really happened to them since they formed. They've just been out there in space, and fortuitously some come to Earth where somebody picks them up, recognizes them as oddball rocks, and little by little we've been able to piece together a really detailed story of those earliest days of the solar system.
So these clues that the meteorites give us, they are landing on top of Earth, right? And not in the order of the billions of years of the formation of the Earth. So those are more recent. Is that correct?
Right. So some are witnessed today. We actually had a meteorite fall in Wisconsin a few years ago, and people found pieces of it. Most of the meteorites that are found on Earth and are being studied are found in Antarctica, not because more fall there, but they're just easier to find there. Out on the white ice, if there's a black object, it's probably a space rock. So yeah, these have fallen over geologic time. Some are still falling today, but they all are pretty much these really ancient rocks from the earliest days of the solar system.
So looking deeper into the Earth's crust and not just what's just recently landed on the surface, what is that story that we're reading in the text in your field that when you can go deeper down?
Well, conveniently, we have erosion on Earth. And so things that were once deep down, at least in the crust of the Earth, are visible in many places, conveniently for geologists to walk around and see. So again, I mentioned that Wisconsin has had mountain building events in the past, and all that remains of those mountains is not the topography anymore, but the rocks that were at the base of these mountains in the middle crust at the time that the mountains were forming. So those give us a glimpse of what might be going on today, for example, in the guts of the Himalaya, where we really can't get access to that in real time. But because of Earth's very dynamic surface environment with erosion going on all the time, the Earth reveals what's inside a mountain belt. And so it's one of the foundational ideas in geology is something with a very long name. It's a very simple idea, uniformitarianism. It just means that the processes on Earth have largely been uniform over time. And that allows us to do this kind of time traveling. We look at ancient rocks, and we can assume that the processes that formed them are things that are going on the Earth today, and vice versa. So we can kind of move back and forth and compare notes. Things that we can't actually observe in real time now, we can look at the ancient rock record. Or things that we look at in the ancient rock record, we interpret them based on our understanding of now.
And from a first person perspective, it seems easy enough for us to have an understanding of quick geological events like volcanoes exploding or earthquakes creating ridges or chasms. How does that compare to some of the slower geological processes, if, say, for the formation of a mountain? On what kind of timescale comparison is there?
Right. So I think one misconception that many people have about the Earth is that all geologic change is slow. And you in California know that that's not true. When you have an earthquake, the Earth is moving faster than we like. But there's a whole spectrum from meters per second, which is the seismic slip rate on a fault during an earthquake, to the plate tectonic background rate, which is about centimeters per year. So one handy way of thinking how fast that is it's about as fast as your fingernails grow, if you are paying attention to that. So it's slow, but it's not so beyond our experience that we can't imagine it. And these days, we can actually see plate motions from space. We have satellites that monitor points on the Earth's surface, and over a matter of months and years, yeah, we can see how much California has shifted. Yeah, so it's slow, but not beyond our capacity to imagine or even experience as human beings.
Yeah, and I think that speaks to one of the phrases that you use, that we should think of rocks as verbs rather than nouns. And again, to help us understand, when we pick up a rock, it feels very solid and feels like it's maybe been this one thing for the whole time. Can you talk a little bit more about what changes some of the rocks we may encounter on a daily basis might have gone through, or and what they might continue to go through?
Right. So every rock is a product of recycling. All the stuff, if we go right back to the beginning, again, started in some ancient star, got incorporated into the young Earth. All rocks ultimately can trace their origins back to the mantle. The mantle melted and then became some kind of igneous intrusion, or maybe a lava flow. Those things were eroded and became particulate matter. That's how sedimentary rocks form. And then those rocks may themselves be caught up in mountain building and become metamorphosed or even remelted again. So, yes, every rock came into being. It hasn't just been there forever. Today, we see it as this solid object, but it has a biography. And yes, as I like to say, they're verbs. There's some process behind them. And I think um, in teaching geology, perhaps sometimes we overemphasize the taxonomic part of just learning rock names. What we really should be, underscoring is the rock processes. These things are records of events, and it's not so much just identifying them. It's reading their stories that really makes geology, for those of us who are in it, such a compelling field. Almost feel like you're reading the history of the Earth.
And so you've talked about how these minerals and rocks kind of recycle themselves almost in closed systems, as the Earth is. So even if we can imagine a mountaintop crumbling and eroding to a grain of sand, that's not the end of the story for those particular minerals. Is that right?
Absolutely. Yeah, a cycle means it keeps going. And if we didn't have erosion and the breakdown of the topography that disappeared, the planet would be utterly different. And we can look at Mars and see how different it is. So, for example, the largest volcano in the solar system is Olympus Mons on Little Mars. Mars is 60% the diameter of the Earth, but it has these really outsized features. And it has this huge volcano. I think the footprint is about the size of the state of Arizona. It's 3 times higher than Mauna Loa, the volcano in Hawaii that measured from the seafloor is about 9 kilometers. Olympus Mons on Mars is 27 kilometers high, and it's been there for 1 billion years. Nothing on Earth, no topographic feature on Earth has been at the surface of the Earth for 1 billion years. Earth is constantly rejuvenating itself. So the familiar look of the Earth to us is all about recycling. Everything is ephemeral. Luckily, some old rocks do persist. So we do have really old rocks to look at, but the fate of almost everything is to be recycled.
How different can we expect the features of Earth to be, say, well beyond our lifetime, but in another billion years? Can you conjecture that far?
Well, again, we can use this idea of uniformitarianism, which broadly speaking, tells us the background rates of processes. Landscape evolution is a complex function of tectonics and climate. Um, so we have some sense of how quickly landscapes can change. In the last maybe 20 years, there have been some really interesting rephotography projects in different parts of the world, including the Grand Canyon region, looking at photographs of particular notable places in the late 1800s and comparing them to today and doing really detailed quantitative assessment of, where have rock falls happened? How much erosion has happened? So we can really calibrate landscape changes. But looking ahead 1 billion years, we have to take into account all kinds of things. Certainly the climate will have changed, and we will be well beyond at that point the current changes to climate that we're causing. Those will have a long shadow and probably last several hundreds of years beyond our time. But over maybe millennial to 10,000 year timescales, we need to start thinking about factors besides greenhouse gases that affect climate, and those can include orbital cycles, the way the Earth tilts, its orbit around the sun. And as we look even further out, we have to start thinking about, will the tectonic system be the same? Probably for the next few 100 million years or so. But at some point, Earth will lose its internal heat engine. The radioactive elements that decay and give up a lot of heat are slowly being depleted. And at some point, maybe in a billion or so years, the tectonic system as we know it, that is driven by this heat engine and the convection of the mantle, might grind to a halt. The sun is also evolving over time as a star. It's a medium-sized star with a full lifespan, probably on the order of 10 billion years. So at this point, it's about halfway through its span. And over time, the sun has become more and more luminous and is putting out more and more radiant heat energy. And that will certainly affect the Earth and the other inner planets. And at some time, maybe in 1.5 billion years or so, it will become very hot and perhaps intolerable to most life forms on Earth. Some may hang on longer. So I don't like to think about that too much, but so there are these very long-term changes. There are also very shorter-term changes. And I think that's one of the hardest things in becoming a geoscientist, to start getting some kind of temporal proportion. How fast do all these embedded cycles take? They're all interacting with each other. Some are way beyond anything humans can tinker with. Others are things we're actually changing. And there are just so many different characteristic timescales. And that's a challenge. It takes some practice and repetition to kind of get used to moving through these different timescales comfortably.
Yeah, and some of these stories you're telling kind of remind us of the privilege of being in the here and now. And we can look to the past and we can imagine the future, but how can we benefit from thinking in this kind of very long-term scale and this kind of geologic time? What's offered to us?
I think that's a really good question, because I know for some people, thinking about this sort of deep past or distant future it's troubling, it's alienating, it's existentially off-putting. But I think, the focus on saying we're here now on this commodious planet that's had this amazing long history and is really complicated. And there have been other residents here, some of which are still with us, ancient evolutionary species that are still here. To me, that really enriches my sense of being an Earthling now. I'm a human, I'm a mother, a daughter. I can feel the pain of the passage of time and losing things that are familiar and people that I love. But there is some kind of solace almost in understanding our deep evolutionary roots in this planet and knowing its story, not walking around like a bad tourist who didn't bother to learn the first thing about the place you're visiting. We're here our whole lives, and I think a lot of us are a little bit that way. We have no clue what the culture of the Earth is, and it's to our own disadvantage. We're missing out if we don't bother to learn about that language and culture. So that's, I guess, what I would say. We have inherited this beautiful green planet, and it's a tough one, it's a resilient one, but it can also change in ways that we might not like under our own watch. So, I think it can engender a sense of humility and gratitude. That's how I would respond to that.
Yeah, and are there other ways of knowing or knowledge gathering that you've encountered or have seen that also afford this kind of look at the present and how we can best kind of use our time here?
Yeah, so here I'm in Wisconsin, and we have 11 Native nations in Wisconsin, of different tribal groups. Most of them are Ojibwe, we have Menominee too, and Ho-Chunk and some others. And I have, as a geologist, been involved with several of the Ojibwe bands who have gotten together as a consortium, really, and they call themselves the Great Lakes Indian Fish and Wildlife Commission. And they're getting good legal representation to make sure treaty rights are observed. So I've interacted quite a bit with some of the tribal leaders on a couple of mining cases where tribal lands where they have treaty rights were threatened by very large mining operations. And so as a geologist, I just testified about the potential environmental effects of these proposed mines. And so in talking with the tribal leaders and their legal representatives, I really did get a sense of a completely different attitude toward human stewardship of the land. Most of these tribal nations are on relatively small reservations. They're not going anywhere. There's no frontier to move to if the land is despoiled. The water resources they have on the land are what they have. If the groundwater is contaminated or depleted from high capacity wells being on a nearby mine site, that's all they got. And so there's a different attitude if you understand this is where we're going to be for the next few centuries. You have a very different attitude about actions that are taken now. So absolutely, I am a scientist and I believe strongly in the power of the scientific approach to investigating the world, but that doesn't always bring wisdom. Wisdom is the human processing of information, and it's something that takes not only smarts, but some kind of humanity. And so I think many of these indigenous cultures, and as I said, the one that I'm most familiar with would be the Ojibwe culture, where you have a very good sense that you too are part of this continuum of time. I think the dominant white capitalist culture of our time is a kind of narcissism. It's the narcissism of now. And that's a dangerous thing because we are making decisions with a blinkered worldview.
Are there any other endeavors or through science that we can engage in that kind of can tell us those deeper stories, or that can help us look towards ways to kind of heal some of that maybe harmful way of thinking?
So you mean as individuals, is ordinary
I guess in
flings?
thinking and acting. Specifically, I'm thinking if there's opportunities in research that can help us undo some of the mess that we might have made on this earth.
Mm-hmm. So what geoscientists are looking into? Yeah, I mean the first thing is just to stop doing the destructive things. And frankly, since I was in graduate school in the 1980s, the job opportunities for geologists have shifted from most of the people that I went to school with went into the oil and gas industry or the minerals industry. These days, a lot of geologists are employed in cleanup operations, in remediative projects. So whether it's groundwater contamination, soil contamination, there's actually a lot of jobs that have been created because of poor treatment of land and water resources. So, we know how to clean things up, but it's immensely expensive. And at some point, people are learning that it's better not to do the mess in the first place. The biggest mess, of course, that we're creating is climate change. And this is going to be something, as I said before, that has a long shadow. Even if we could stop emissions today of carbon dioxide, a lot of that is going to be in the atmosphere for the next century or two. So there are, in addition to cutting emissions and doing everything we can there are a growing number of geologists, including hard rock geologists, who are turning their research away from the traditional studies of igneous and metamorphic rocks, say, to carbon sequestration strategies, using the earth itself as a kind of mentor. People might know of the idea of biomimicry, which is in design. You look at how nature does things. I think I've heard that Velcro was invented because it's just like, burrs that stick to your clothes when you're outside. So that was an idea that came from the botanical world. Well, we could use geomimicry too. Look how Earth has put carbon away over time. the main carbon sequestration mechanism that Earth has is limestone. Unfortunately, limestone accumulates very, very, very slowly. And another bad thing is that in increasing the partial pressure of CO2 in the atmosphere, we're actually making oceans more acidic, and that makes it harder to form calcite. But there are some people that think maybe we could artificially make calcite by injecting carbon dioxide with very reactive rocks of a certain type. And there are experiments going around the world, in California, in Iceland, and a few other places, to see if maybe this is one strategy in the range of things that we need to be doing to clean up our climate mess. It's not going to be the panacea or a silver bullet, but it might be one of a suite of options. Although, frankly, at this point, the most efficient way to sequester carbon dioxide is just plant a tree. It's not forever, but at least it's, decade to century scale carbon sequestration.
And so, what are some of the other chapters, let's say, in the story of Earth that are still kind of curiosity to you, or what
Mhm.
else are you interested in researching or can see discovering in our lifetimes?
Well, I do have this irrational yearning, really, to be able to go back and visit certain times in the past. Um, Certainly one that I'm very interested in, and I have spent some time looking at rocks of this age, is the whole snowball Earth episode. So this is not just the ice age that happened the other day, as I always say, the Pleistocene. This was an ancient ice age that happened about 700 million years ago, and it seems to have been extremely deep and long and severe, to the point where we can see rocks that formed at that time that are clearly glacial deposits that formed at sea level at the equator. So this is an extreme ice age. And then how we fell into that, what was really going on? Was it really like Earth was a hard snowball, or was it more of a slush ball? And then how the Earth got out of it. There are many hypotheses about this. And almost immediately after the end of this episode, we see the first macroscopic animals. And so that period of time between about 700 million and 550 million years ago is, if I could do some kind of flyby, of course that's a very long period of time, you know, and many geologists are interested in this, and of course it's very controversial. Many papers are written about this, but it's such a peculiar time, and in some ways it ushered in the modern world. Again, macroscopic life suddenly flowered after life had been around for 3 billion years as microbial life forms mainly. And then all of a sudden we have a macro biosphere. And the modern composition of the atmosphere basically came at that time too. So I see it as Earth's maturation into its sort of adult state. So that's a fascinating time. Another would be a more sobering time, the greatest mass extinction ever, which is not the dinosaur extinction, which only is the fourth worst. But the biggest, baddest one was the Permian extinction about 250 million years ago. There's no evidence it was a rogue meteorite that came slamming into the Earth. It was probably something that unfolded over maybe 10,000 years. So it wasn't sudden by human standards, but it was severe. And something like 95% of all the marine fossil species that we know of vanish. And it was a kind of perfect storm of a lot of different environmental things that collectively acted to make the environment suddenly very inhospitable after a thriving period of hundreds of millions of years. Suddenly everything collapsed. And that's very sobering, because many of the factors that contributed to that episode look familiar to us in the Anthropocene. Sudden spike in greenhouse gases, mainly from volcanoes, ocean acidification, ocean anoxia, like the dead zones in many of the world's oceans today, and they all converged at once. And it was a very bad time. So I don't know if I want to visit that one, but it's intellectually compelling, because you want to know what on earth happened. So those are a couple of examples.
And those speak to incredible periods of change and sometimes even relatively rapid change. So we can expect more change from this Earth as it continues its journey. And I just want to close for our viewers or visitors. What's one small way that we can all engage in geology or geologic thinking, or coming to appreciate the Earth as you've come to appreciate it through your years of study and research?
Yeah, and I think it is easy. You don't need to study geology necessarily, but just kind of getting to know the ground beneath your feet, the familiar landscape that's where you are. And luckily there's so many resources. I know the Exploratorium has fantastic maps of how the San Francisco Bay Area has changed over time, but pretty much every state has a geological survey, which has free maps. They're paid for by taxpayer money, so you can download geologic maps, soil maps, groundwater maps, plus a lot of useful information about understanding some of these processes. And I think just getting to know things by name, it develops a relationship with these things. And then that can be a scaffolding for expanding beyond your particular patch of land outward. So it's easy. Just dip a toe in, get a little bit of information, and then you're on your way.
Well, thank you so much for sharing your time, your research, and some of the wisdom that you've collected over your study of the Earth.
Thank you, Sam.
Now we turn to our first installment for the Odd Salon Decay residency here at After Dark Online, curated by Kate O'Donnell. Since 2014, Odd Salon has been bringing curious minds together for live salons over cocktails, encouraging both experts and amateurs to take the stage and explore extraordinary and unusual chapters from history, science, art, and adventure. They are a community project centered around a fellowship of speakers and an extended family of members. We hope you enjoy this first installment. Take it away, Kate.
Hi, welcome to Odd Salon Decay, an Exploratorium residency. My name is Kate O'Donnell. I'm a senior project specialist at the Exploratorium, but I'm also a fellow and curator with Odd Salon, and that is the flavor of nerd hat I am wearing tonight. Odd Salon Decay is being hosted over the course of 3 different After Dark onlines. We're going to talk more about that in just a moment, but first let's talk a little bit about what Odd Salon is, if you are new to Odd Salon. It is a community project, an evening lecture series featuring stories from the odd corners of history, science, art, and adventure. Founded in San Francisco, we now have an New York chapter as well. And one of my favorite things about Odd Salon is the same reason why it's such a great partner for the Exploratorium, which is that it is entirely interactive. Yeah, we like the audience to shout at us, but more than that, we like the audience to become the speakers. So if you would like to speak at one of our upcoming online salons, please join us on Facebook and the email list to keep up with our upcoming events and calls for submissions, or send in your genius story ideas to oddsalon.com/speak. Now, as I mentioned, we are normally not a quiet show. The yelling call-outs thing, though, works a lot better in person, but if you needed an extra excuse to yell at your computer, we got you. Here are some of our regular callbacks. Ships, science, maps. Odd Salon is more than just a show. It is a real world community made up of our speakers and fellows and our rowdy, shouty audience. So to keep in touch during these very weird pandemic times, we are holding regularly scheduled private virtual events for fellows, members, and Patreon supporters. The next one coming up is a sip and learn happy hour lesson in stencil making with one of our fellows. If you are interested in joining the community, check out the Odd Salon membership program where you can gain access to ongoing private events and discounts. On to tonight. So we're experimenting with a new format for this residency. Typically in person, you'd be seeing 6 talks in a raucous hall of delightfully nerdy weirdos. But this month, these talks are spread out across 3 nights as we tackle the subject of decay through different lenses at After Dark Online. On October 29th, we'll be looking at decay through the lens of how our scientific understanding of the world has evolved over time. On October 15th, we study decay from the biological perspective. And tonight, at After Dark Online, Dusk to Dust, we examine decay through geology and geologic time. We're going to be hearing about America's first female geologist, and we'll be examining the concept of the Anthropocene and the human imprint on geologic time. But first, let's take a few minutes to examine tonight's theme. Now, when we think about decay over deep time, we get it. But I do think our short lifespans at least partially preclude us from fully grokking a geologic timescale, with one very notable exception. For millennia, human beings have contemplated eternity. The basic idea of a soul remaining intact through the end of time is something believed by so many ancient cultures around the world and by many major religions today. And when I think about decay, through every lens we're using, deep time, biology, dead science, and every Odd Salon angle of art, history, science, and adventure, there's one person who comes to mind. Qin Shi Huang, or Qin Shi Huangdi, the self-named first emperor of China who lived over 2,200 years ago. We'll be exploring his story throughout this residency. Tonight, Qin Shi Huang faces the afterlife. Qin Shi Huang is one of the most fascinating characters in history. Terracotta warriors, that guy. Great Wall of China, that guy, at least the beginning of it. Ending 250 years of war and unifying 7 states, forging the civilization of China that we largely still know today, that guy. Standardizing roads, creating a national monetary system, standard writing system, some of which is still used today, standardized units of measurement, among many other things, that guy, that guy, that guy. Qin Shi Huang has some of the most outstanding accomplishments in history. He was also, as maybe more believable from this more angry representation of him, responsible for the deaths of hundreds of thousands, if not over 1 million people, including members of his own family. He burned books, instated incredibly draconian laws, and is generally thought of by history as a cruel tyrant. All the info we have from him is from the folks who overthrew his dynasty after he died, so like maybe a minuscule grain of salt. But I think it's fair to say he was, at best, a complicated man. One thing we know for sure, his obsession with immortality. This obsession, and that is definitely the right word for it, is something we'll be looking at throughout this Exploratorium Odd Salon residency. Qin Shi Huang's goal was to never need a grave, but he built one for himself just in case. One that is basically the most incredible tomb on Earth, and that is where we are going. Enter Rivers of Mercury. Okay, I'm sorry, spoilers. That is my favorite part, but we're not quite there yet. We'll get to it in a minute. We're going to start instead in 1974, when some farmers in the village of Xiang, China are digging a well. They come upon some arrowheads and shards of terracotta. Some archaeologists catch wind of it. 2 months later, a team of scientists begins to dig up what will later be designated a World Heritage Site. This. Thousands of larger-than-life warriors lined up in battle formation, every single one unique. And I don't just mean some of them are like kind of smirking, some of them are not. We are talking individualized statues of different people. Scientists have used facial recognition technology to see if they can find ones that are the same. They can't. Some believe the statues were, in fact, individual portraits of Qin Shi Huang's army. And like other things in this necropolis, it is the scale that really boggles. Scientists believe there are about 8,000 warriors. Almost 7,000 have been found. They were made by hand by a relatively small team of artisans in just 11 years, in a style and technique far beyond the craftsmanship up to that point. And I know, you've all heard about the terracotta warriors before, but they cannot be fully understood out of context because in context, they are just the tip of the iceberg. This is a map of what we know exists. See that mound in the middle? Yeah, that's this mountain. There is literally a palace under it, a pyramid-shaped structure greater in volume than the Egypt's Pyramid of Giza. The warriors are just in some pits off to the side. This is the largest known burial site on Earth, 200 times bigger than the Valley of the Kings in Egypt. It is the most grandiose answer to the question, if you had to pack for eternity, what would you take? For Qin Shi Huang, that answer was a lot. Sure, you've got a whole army to protect you, but what about the rest of court? You definitely want to have a good stockpile of armor, some chariots, plural, with life-size bronze horses, acrobats, entertainers, and birds, because birds. Unfortunately, this is where the packing list loses its charm. Many people were killed in order to be buried with the emperor to join him in his next life. These, unsurprisingly, included the emperor's harem, empresses, consorts, and concubines put to death and placed in pits near the mausoleum. And yes, I know this beautiful painting does not feature any Qin Dynasty dress, but believe me, it's a lot less upsetting than the pictures of the pits. Some historians believe that many went willingly in order to join Qin Shi Huang in the next life. And this point is actually really important, as it is critical not to fall into typical racist tropes by imposing modern Western views on ancient culture that one doesn't fully understand. That said, I'm not sure that some of them probably consented really makes the male violence against women and sex workers bit any better. But it wasn't just women. In fact, if we take another look at the map of the mausoleum complex, we see some pretty grim listings, including slaughter pits, punished convicts, and mutilated skeletons. Those buried with the first Qin emperor also included the builders of the mausoleum itself, for they knew the secrets which they were forced to take to their literal graves. They were literally sealed in alive, which is why our only account of the necropolis comes from about 100 years later in the records of the Grand Historian, which brings us to the mausoleum and some serious Indiana Jones, but less racist stuff. The main event tomb inside the underground palace is believed to be pyramids surrounding an about football pitch-sized main area, all buried beneath a mountain. I say believed to be because, unlike many of the pits surrounding it, the mausoleum of Qin Shi Huang has intentionally never been opened. Why? There are a number of reasons, some of which are going to become immediately evident. Here's the thing. If you are packing for eternity, you have got to make sure no tomb raider comes in after and steals the stuff that you need for literal eternity. In other words, it's booby trap time. Passing through the entrance into the tomb, legend says, one will encounter everything from automatic crossbows to quicksand, a walkway of rotating plates with spikes at the bottom to sleeping fire that combusts only when the tomb is opened. The totally bananas thing is that, given what we know about ancient China and other tombs, science backs it up. Like, it's not all just possible, but plausible. We know for sure that the automatic crossbows were a thing. Here's a recreation of one. And it gets nuttier. That's right, it's time for Rivers of Mercury. In the records of the Grand Historian, it's written, quote, Mercury was used to simulate the 100 rivers, the Yangtze and Yellow River and the Great Sea, and set to flow mechanically. Above were representation of the heavenly constellations, below the features of the land. Now, many historians believe that the reference to the constellations indicates the ceiling inlaid with jewels to mark the stars. But surely the Mercury River map must be legend, right? Wrong, of course they're real. This is Qin Shi Huang we're talking about in an underground palace. Scientists have conducted multiple rounds of soil sample tests and found alarmingly high levels of mercury in the shape of the Qin Empire, with the highest concentrations where the rivers would be. I wish I had more time to talk about this mausoleum because it simply astounds. What's super cool is that because there are so many mysteries still, there's also so much science going on that we can follow along with. There is, shall I put it, no shortage of TV documentaries that have the line, but the mysteries of the first emperor's tomb have never been confirmed until now, before cutting to the results of the science experiment. Like, so many. But it is really cool to see the results of experiments like that, like the Mercury one, unfold in real time. It doesn't have to all be mystery, right, though? Why don't they just open the tomb? Well, aside from the booby traps and potentially fatal levels of mercury, the real answer is the same one of Qin Shi Huang's strongest motivators in life: fear of decay. The weapons carried by the terracotta warriors have lasted and are actually a stunning example of metal preservation techniques, way ahead of their time. But those monochrome terracotta warriors were actually originally brightly painted in beautiful, stunning colors, including the rare Chinese purple. Unfortunately, archaeologists have about 15 seconds to see a warrior in full color glory after it's unearthed. The raw lacquer used to attach the paint to the warriors is particularly prone to dehydration. So, especially after more than 2,000 years in the ground, as soon as it's exposed to the dry air, the moisture in the raw lacquer beneath the paint evaporates, and the paint begins curling and falling off before your eyes. Literally 5 minutes after the unearthing, your man on the right will look much more like your man on the left. So there is a very real and very valid concern that opening the tomb will lead to similar decay of its contents. So maybe it's time to let time be until science catches up with the preservation techniques we need. As we'll discuss in the coming weeks, Qin Huang railed against decay in his lifetime. So it does seem fitting that scientists are now doing the same for what he left behind. And so I would like to raise a glass to tonight's invocation. A quote by Edvard Munch: "From my rotting body, flowers shall grow, and I am in them, and that is eternity." With that, cheers. Please welcome tonight's speakers, founding Odd Salon fellow Amy Widdowson, and for their first time on the Odd Salon stage, all the way from England, former Exploratorium fellow Kit Rackley. Welcome, you two. Amy, take it away.
Hi there. My name is Amy Widdowson. I live in San Francisco in Hayes Valley, and I have the honor of getting to talk about Florence Bascom, America's first lady rock star. So I want to start with a quote from Florence Bascom. Quote, "The start in my case was made in a time, not happily past, when a career in the case of a young woman was not taken for granted. I know more than others took it for granted, and therefore there was no planning. Each step was taken rather desperately because of inner urge, with little premeditation and less expectation of success." That's quoted in Becoming a Geologist, Florence Bascom and Johns Hopkins. So there's a story about Florence Bascom that may or may not have happened, but part of me sure hopes it did. It involves her getting stopped while doing her fieldwork on her seminal paper, the one for which she is known, The Structures, Origin, and Nomenclature of Acidic Volcanic Rocks of South Mountain. For she was on South Mountain, and she got stopped by a man asking why she was there. You see, back in the 1890s, women weren't exactly free to study anywhere they chose. Rules of propriety and good manners dictated that good women were raised to be good wives, able to manage a well-kept home, not pursue PhDs and other distractions. And because of this, the heroine of our story had many challenges because she wanted to be a geologist. And to be a geologist in those days, not only did one have to be accepted into a university, but one had to do fieldwork in order to make a name in the community. One had to get out into nature and see the millions of years of geologic formation around her to test hypotheses of unheard theories of how the earth we stand on came to be. But performing fieldwork required one-on-one time with one's advisor. And in Bascom's case, like nearly everybody else's, her advisor was a man. And why did this matter? Well, because she was a woman, and it was the late 1800s. Florence Bascom is now recognized as an integral part of the founding of her field. Her eventual work identified various rock structures formed by volcanoes millions of years ago. She couldn't label her work within the existing nomenclature, so she came up with her own prefixes, meta, epic, and ap, to delineate acidic changes in rocks. And she hypothesized additional erosion cycles in the Piedmont area of Pennsylvania, a hypothesis that influenced scientists for generations to come, that the area had been created over at least 9 erosion cycles, not the 2 to 3 originally thought. But that was to come. So let's get back to the beginning of the story. I wonder what she thought, having been stopped by a man while on South Mountain, knowing nothing of her research, someone who knew nothing of her upcoming accomplishments, asking her who she belonged to, as if she was a pet off leash, asking which male was responsible for her. To be asked, and I quote, "I want to know what relation to you is the man who goes about with you." Imagine the glances and halted explanation that yes, you were a woman, and no, this wasn't your husband, but he's your advisor? And just as the scandal began to peek its misogynistic head over the crest, your advisor jumps in and explains that yes, his wife is on the trip, and she's just back down at the hotel where the 3 of you are staying together. Imagine all of that drama just because you wanted to map and study the rocks beneath your feet. So this is a brief overview of how Florence Bascom overcame society's view of her gender and became one of the first lady rock stars. By the way, I thought I was super clever with the rock star jokes, but it turns out that the USGS website made all of the rock jokes I was hoping to make and made them better. I encourage you to find that video. Florence Bascom lived in one of my most favorite periods in history. She lived to see the absolute upheaval of empires, the rise in the scientific method and classification of nature, And she was the child of enlightened parents hell-bent on ensuring their daughter was educated and successful. There's a reason why so many of our Odd Salon talks are about this time, about the fin de siècle, because this was a time of firsts. And Florence Bascom herself was a plethora of firsts. She was the first woman to receive a PhD from Johns Hopkins in 1893. And by the way, it was covered by papers across the country. She got a letter when she received her PhD from the president who stated, quote, "You have won your honors as you must have wished to win them without any favoritism, just as all other candidates among us have won their diplomas by talent, patience, and exertion." She was the first woman to work for the U.S. Geological Survey in 1896, the first woman to earn a master's degree in geology, the first female geologist to present a paper before the Geological Survey of Washington in 1901, first female officer of said society, and in 1930 became the second vice president. And in the first edition of American Men in Science in 1906, she was ranked among the top 100 leading geologists in the US. She was among the first geologists to map the geologic provinces of North Atlantic and Appalachian regions by hand, and geologists considered her to be, quote, "the first woman geologist in this country, America." So here we are. Obviously, if I was going to be talking about one of the founding mothers of geology, I had to make sure I checked in with our resident Odd Salon geologist, Miles Traer. And according to Miles, in addition to her drive and her talent, Bascom entered the geologic field at a critical time in history, a moment in which the very nature of geology was being stripped down and examined. You see, before this period, geologic evidence was interpreted through the lens of catastrophic acts to explain aberrants or changes. You know, biblical floods, locusts, plagues, etc. Miles reminded me that she came into this world among massive scientific upheaval. By the time she was born, Charles Darwin's Origin of the Species was a hit, and William Thomson, aka First Baron Kelvin, was already using thermodynamics to attempt to age the Earth. So, between Darwin's theory of evolution and Kelvin's insistence that the world was actually 20 to 400 million years old, not a couple thousand, new ideas were flipping the bird to Bible literalists who'd been, to this point, the main arbiters of rocks and such. All of this seems quaint to us now, I'm sure, but just imagine entering a field in which everything we thought we knew was up in the air and ready to be challenged. That was the time that Bascom started practicing in. Florence Bascom came from a perfect environment for her first. Her mother was a suffragette. Her father was president of the University of Wisconsin, and he worked hard to ensure she could get her education. On the podcast STEM Fatale, which kudos on the name, by the way, the hosts make the point that while many of these early women pioneers had to rely on a male family member or spouse to get them into the universities they wanted to study at, many of them went on to train further women in the fields they specialized in. More about that later. Bascom took cues from the best. While she was teaching at Rockford Cemetery before she went to Johns Hopkins, she was, quote, exposed to Mary E. Holmes, unquote, who had been the first woman to receive a PhD in paleontology from the University of Michigan. At the time Bascom started teaching at Rockford, Holmes was elected as a member of the Geological Society of America. She was an avid scientist and collector, having possession over, quote, countless minerals and fossils and hundreds of geological, botanical, and historiological slides. I bring up Mary Holmes to demonstrate that Florence Bascom had a point of reference. She had an example of a successful female scientist making waves in a male-only field. By the way, the photo before and this one have nothing to do with Holmes's work or where she taught. I just did a previous talk on specifically the Smithsonian and wanted to include it. At the time Bascom wanted to study to become a geologist, this just wasn't done for women. Many major research institutions didn't even allow women to matriculate. Remember, and as Miles reminded me, most educators believed, quote, we ought to recognize that the average girl has a natural disability for mathematics, unquote. Miles would like me to remind you that it bothered him to even type that quote into an email for me. So anyway, early in her career as a member of the faculty at the Rockford Seminary, she was required to teach a 23-hour course load of zoology, botany, geology, algebra, and a Bible class. She was not pleased with this, and her father suggested she just refuse to do so, which of course was not something a woman in her position could do. Bascom was a good and well-liked teacher, and she was successful in teaching students and raising funds and awareness for the work they were doing. But that wasn't enough for her. She wanted to finally complete the PhD she'd started at the University of Wisconsin. She wanted to apply to Johns Hopkins, but there was this wee wrinkle. They didn't accept women. So she used her network, and her professor/university president father did the same, and so she was able to apply. According to Becoming a Geologist, quote, each female candidate's credentials had to be weighed on a case-by-case basis to prove that there was no way they could get the specific education at any other college. And by the way, they couldn't register as regular students, which meant no tuition, yay, but also no scholarships, no fellowships, no prizes. And they couldn't attend lectures unless specifically invited to by the faculty. Luckily, one of BASCOM's biggest champions was also someone she'd worked with previously. When George Huntington Williams took BASCOM under his wing, she had the connection and influence she needed to embark on her studies at Johns Hopkins. But as mentioned before, fieldwork was needed, and there were some strange complications. For one, Florence was 30 and George was 36, quote, relatively young and close of age, which had a potential for scandal. After all, as our current vice president has demonstrated before, it is impossible for a man and a woman to be in the same room without a chaperone. So, to ensure that BASCOM was receiving the proper education without anyone's reputation being torn asunder, Williams's wife volunteered to accompany them on those trips so that she'd stay at the hotel while the two of them went up and did their job. And spending the time in the sun and dirt wasn't exactly an activity for a lady with issues that male geologists didn't exactly contend with, like big, billowy, heavy skirts and parents worried for your well-being. Studying at Johns Hopkins was not easy, especially for a woman trained in coeducational institutions while living at home with her supportive family. Now she was living on her own and having to take her classes, this is for real, separated by a sheet or divider to prevent the male students from being distracted by her feminine wiles. But she was able to do her fieldwork, which meant she was where she wanted to be, out amongst nature and rocks, exploring and documenting and hypothesizing based on what she saw. And this was where she was most at home. She wrote this poem entitled A Hut. The hut, a hut and a tree, and a hill for me, a dog, a horse, and upland meadows, and I'll ask no thing of man or king, save to clear away their shadows. So let's review. Dr. BASCOM enjoyed many privileges that helped her achieve what she ended up achieving. She came from a curious and liberated family that celebrated working women and encouraged their independence. She had a university president father, as we mentioned, who leaned on every connection he had to ensure his daughter had a place at a research school. But Dr. BASCOM wasn't merely content succeeding on her own terms. One of the great legacies of her work is the legion of female scientists she trained and launched into the profession, some of whom ended up challenging her very theories. She trained an entire generation of geologists. And geology graduate program she created at Bryn Mawr eventually became one of the most rigorous in the country, with both lab and field work for her female students. In order to facilitate this much needed fieldwork, she even requested that her and her students be allowed to go off campus in what was called an athletic skirt. The president of Bryn Mawr said no. And here she is with her students at Bryn Mawr. Helping clear the trail for future women in science was BASCOM's MO. Before she came to Johns Hopkins, she fought for a new science center at the all-woman seminary school, insisting on the highest quality labs and libraries. And she even ended up taking some time off to study petrography, mineralogy, and crystallography, but she came back to teaching so that she wouldn't become so specialized that she couldn't instruct students in the courses offered. She wanted to continue to impart knowledge. Look, she wasn't blind to the challenges her and her students faced. She was quoted as saying, quote, "When any woman manifests an interest in the science, I am always glad to tell her of its possibilities, and she makes her own choice. Not only must a girl have the mental aptitude for scientific research, but also physical strength and great physical courage. Then, too, she must be strong in the conviction that it is the work she really wants to do." Her teaching continues. The USGS still has a geoscience center named after her. So I want to end, this is an abbreviation of one of my favorite quotes from her, but I'll read the full quote now. "The fascination of any search after truth lies not in the attainment, which at best is found to be very relative, but in the pursuit, where all the powers of the mind and character are brought into play and are absorbed by the task. One feels oneself in contact with something that is infinite, and one finds joy that is beyond expression in sounding the abyss of science, and the secrets of the infinite mind. So please raise a glass to the eventual decay of sexism and misogyny in science, and to those who help the process move along. Cheers.
Joy in sounding the abyss of science. I love that so much. Thank you, Amy. Up next is Kit Rackley with The Anthropocene. Does Arrogance Outlast Decay? Kit, welcome.
Hi, my name is Kit Rackley. My pronouns are they, them, and I am from the United Kingdom. So the Anthropocene, it's a unique period of Earth's history in which humans are one of the dominant forces of nature. But the debate is still feverish whether we should be formally designating the current period of history with this term. And perhaps it's a term of arrogance too. Are we having such a profound impact on our planet that when, not if, decay sets in, our mark will be forever present? So let's take a look. The concept of the Anthropocene has been around amongst scholars for over 150 years, but it was Soviet mineralogist and geochemist Vladimir Vernadsky who in the 1920s first pioneered the thought that living organisms could reshape the planet as surely as physical force. He was a man who was so dedicated and passionate that despite all of the aspects of the early 20th century that impacted his everyday life. And on top of this, his work was actually largely dismissed by the West until decades later. But he is recognized as pretty much the father of environmental sciences, which is something close to my heart because I've got a degree in that. So scientific controversy was as rampant then as it is today. Now, fast forward to 2011, and a Nobel Prize for Chemistry winner said this: "It is a pity we're still living in the age called the Holocene. The Anthropocene, human dominance of biological, chemical, and geological processes on Earth, is already an undeniable reality." Now, he got into an argument with some of his colleagues, which made his blood boil. This passion and arrogance came from Dutch chemist Paul J. Crutzen. Months later, this snarling, fire-breathing person teamed up with American biologist Eugene Stromer and expanded and popularized the concept of the Anthropocene. But okay, let's just move the origin story to the side and turn to context. Let's use Crazy Horse's arm for scale. If Earth's lifespan, all 4.5 billion years of it, is his armpit, then the Cambrian explosion, the trilobites, didn't occur until the knuckles. Then here's the dinosaurs on our upper finger with the meteor strike 65 million years ago at the end of that. And we didn't come about until the distals of the fingernail. So that's the bit that overhangs that sticks out and overhangs. And us trolling the Earth, well, that didn't really occur until the microscopic parts of it. So next time you bite your fingernails, you've just erased all of human history. Now, okay, I'm a bit of a sci-fi fan, a bit of a fancy fan. So here's a bit of a thought experiment from The World Without Us by Alan Wiseman, a really good book from 2009. So I want you to just think of this. What if Thanos, instead of getting rid, spoiler alert, if you haven't seen Avengers Infinity War, spoiler alert there. If Thanos decided to click his fingers and get rid of everybody instead of just half of the human population, what might actually happen? What would set in decay-wise, and what kind of legacy would we leave? What would of our arrogance would be left behind? Well, let's take a look at this, shall we? What might endure? So start from something on my side of the pond here, the Channel Tunnel, or the Channel as we called it, which connects England and France, and it's built within the rock underneath the English Channel. Now, it may actually remain passable for a while to allow migrating animals until sea level rise floods the French end. But continental movements after about a million years will be the death knell for it. Now, but what it does tickle me to think that it would grate Nigel Farage, Brexit stalwart, to learn that this physical legacy of joining Britain to Europe will long outlast his efforts to separate the EU and the United Kingdom. Sorry, Nige. Okay, so what about everyday stainless steel items, such as nunchucks? What about odor bars to get rid of that pesky sulfur smell? What about chainmail gloves? Now, these would last millions of years if they ended up being buried and fossilized. This one, Mount Rushmore in South Dakota. Now, it's carved out of granite with intrusions of pegmatite, especially resistant to weathering, eroding only 1 inch for every 10,000 years. So noses will be gone within 2.5 million years. Heads would lose their definition around 7 million years. Typical, isn't it? The epitome of privilege that a monument to a bunch of white cisgender old dudes would last for so long. So let's decolonize that. The monument to Crazy Horse, also made out of pegmatite granite. It's planned to be larger and more defined than Rushmore, so let's get Crazy Horse finished before Thanos, and so we can outlast those colonials, eh? This one, I know I'm cheating here, but the human artifact that is most likely to last into billions of years is within an environment that lacks weathering and erosion agents. Activity on the moon, but knowing our luck, probably a meteor strike will blow all that up. Now, okay, I haven't covered the usual suspects, atmospheric carbon, petrochemicals, mass extinction, because they get enough coverage as it is. So let's just focus on the root of these, human arrogance. And we can flip the title of this talk. Does it cause decay? So maybe the Anthropocene shouldn't be an era, but more like an event, like the meteor strike that hit the Earth and caused the extinction event, the KPG extinction event. So here it is, with a Swiss Army knife for scale, just that little thin sliver. So sticking with scale, here we go again. Let's make these extinction events thickness on these lines to represent how long they've actually lasted. So focusing onto my finger here, here's the meteorite. Here's us trolling the Earth. Well, if we be generous and say go back to the agricultural revolution, that's 15,000 years since then, and 185,000 years is the gap between seeing dinosaur fossils and the new mammals. Well, that's 12 times more time span than what we're doing currently right now. So, but it must be said that with extinction events like the KPG boundary and the dinosaurs, now, once that happened, there was an explosion of life. When the dinosaurs went, then the niche that was left behind by all these dead animals were filled in with all these with these mammals. So let's think of this. With current events, how might evolution take place? How might it grow from our decay? Well, to quote Star Trekkin from 1987, it will be life, Jim, but not as we know it. Here's some possibilities from a BBC article. I'm British. I love the BBC, so this is pretty good. Let's look at a few of these examples. So the climate will be changed, things will be hotter, things will be, animals might need to try and pull moisture out of the air. So think of this. Larger animals might evolve things like extended sails or skin flaps that could extend out of the early morning to capture the moisture. Now that is from Patricia Brennan, who's an evolutionary biologist. Now, the frilly collars of some lizards, for example, could become very large and exaggerated to gather water in this way. So here's my mock-up. How about the frilled-necked lizard from New Guinea and Australia plus fog harvesting nets in Peru equals the fog-necked lizard? I don't know. Looks quite pretty, doesn't it? Right, okay, so what about this, which you may or may not have heard of, the 19th century hoax of the Madagascar man-eating tree, or the myth of the Yataveo, the latter being a carnivorous tree with huge poisonous spines? Well, we already have today the walking palm tree, native to Central and South America, and of course the famous Venus flytrap, so who knows, within a million of years or so evolution. Indulge me one more time. With potential long-term disruption to habitats, there may be a necessity for species to habitat switch. Consider a toad whose gullet swells outwards, large gas bag used to make mating calls. We've all seen Planet Earth. Now, what if that toad evolved to be able to fill its gas bag with hydrogen from the water so it can hop further or even float? No longer a need for legs, so maybe they become tentacles, and through natural selection, they become bigger to survive predators. Result, a zeppelinoid. Now they would become predators themselves, ensnaring their prey in their tentacles. Here's a deer for scale. It's quite scary, doesn't it? Okay. Now, I began with a quote from Crutzen, which on behalf of humanity has a tone of arrogance. But to end, I'll return to Vladimir Vernadsky, who in 1945, the year of his death, said, "The whole of mankind put together represents an insignificant mass of the planet's matter. Its strength is derived not from its matter, but from its brain. If man understands this and does not use his brain, his work for self-destruction and an immense future is open before him in the geological history of the biosphere." So, I would say that's a warning to humanity of their arrogance. Now, life will go on after decay, whether it be mass extinctions from geological upheaval, asteroid strikes, or sheer bloody arrogance. And so I'd like to give us a little bit of hope with a toast. And that is, we may feel that the events of today is causing decay in some form or another, and what comes next may be inconceivable or uncertain. What appears to be inevitable is that from decay becomes rebirth and an explosion of diversity and evolution. So here's to what comes next. Cheers.
Thank you so much, Kit. I don't know, I think I want to stay around for some of those carnivorous trees. So that concludes part 1 of our Odd Salon Decay Exploratorium residency. Please join us for After Dark Online on October 15th and 29th for more. If you liked what you've seen and want to connect with this wonderful community and learn more, join Odd Salon's Facebook group, Something Weird, or visit oddsalon.com. Thank you. Good night.
Thanks for continuing to learn with us here at After Dark Online. We'll finish off this evening with a brand new recorded performance as part of our Resonance series. We hope you enjoy, and we'll see you next week.